Welcome back to the second episode in the series, Realistic Scenarios. Now, today we are going to be looking at first packing two compatible cargoes into a given container utilizing the Stowage Factor Formula. We'll also be looking at how to calculate the volume usage as a percentage. Also, how much of a particular cargo can be safely loaded into any container using the payload and the weight. Now, this is a typical scenario from a hardware that this happens frequently. It reads, SA Ray Construction Limited ordered two consignments of construction material to complete a dwelling house in West Bay, Portmore, from Mac Hardware. One consignment consisted of 250 bags of thinset, each weighing 35 kilograms, with a storage factor of 1.3 cubic meters per ton. The other was 60 drums of asphalt with a storage factor of 0.7 cubic meters per ton. Now, each drum measured 800 millimeter high and 600 millimeters in diameter. Now, as a logistician, you were contacted by Mac Hardware to deliver these material to SA Ray's construction. The question continues. The 20-foot container that you're asked to pack these two compatible cargoes in has an internal volume of 31 cubic meters and takes a maximum payload of 18.7 tons. The 40-foot container has an internal volume of 67 cubic meters and has a maximum payload of 27.5 tons. Among the questions that they ask, A, could both consignments be packed in a single 20-foot container? B, what is the volume usage in percentage? And C, how many thinset could be allowed to be packed and safely transported in a 40-foot container? So we'll be using the given specs for the 20-foot to calculate A and B, and C will be using the specs for the 40-foot to calculate how many thinset can be transported safely. First, we need to identify what is given for each consignment. So let us look at the thinset first. We are given 250 bags, each weighing 35 kilograms, with storage factor of 1.3 cubic meters per ton. So therefore, we need to find the volume. For the asphalt, we are given 60 drums, each drum measuring 800 millimeter high and 600 millimeters in diameter. We are also given storage factor of 0.7 cubic meters per ton. So we need to find the weight for the asphalt. In any of these calculations that you might come upon, it's best to break them down like this. What you're given for each consignment and what you need to find for each consignment. So let us look at the solution for the thinset. The weight of the thinset is 250 bags. Each bag is 35 kilograms. Therefore, this gives us 8,750 kilograms. Now, since 1,000 kilograms is equal to 1 ton, then the weight is 8,750 divided by 1,000, which gives us 8.75 tons. Now, transposing from the stowage factor formula, we have already determined the weight, so now we want to find the volume, where volume is equal to the weight times the stowage factor. 8.75 times 1.30 cubic meters per ton would give us the volume of the thinset. That is 11.38 cubic meters. Now, let us solve for the asphalt. Here we see, as in the previous video, where because of the round drums being placed in a rectangular container, broken storage areas are created. Now, let us solve. We have the height of 800 millimeters, and since we know that 1,000 millimeters is equal to 1 meter, then we can determine the actual height in meters. It is better to work in the larger unit since we don't have to use very large numbers. All right, so that would give us 0.8. Converting the diameter, we have 600 millimeters divided by 1,000. That would give us 0.6. Now, the volume of a cylinder, as you know, is pi r squared times the height, which is 3.142 r squared times h. This formula should not be used to calculate the volume, as I explained earlier about the broken storage resulting from the round drums. Now, in shipping, someone will have to pay for this space. All the space that is lost, someone will have to pay for it. And so, in calculating the volume of the cylinder, we would use a cuboid. Now, let us look at how this would work. Because the volume of a cuboid would be the diameter. We would have the diameter as can be seen there. Here we see the diameter of the cuboid, which would be the diameter of the actual cylinder as it is placed. The broken storage area this time, all of these areas would be captured. They would be actually captured. And so we would fit the cylinder in the cuboid. As we said, the diameter of the actual circle would be equal to that of the cuboid. We therefore can use the formula of the cuboid, which is the diameter squared times the height. Doing so, we will capture all the space, those broken storage spaces. Now, here the volume of one drum would therefore be equal to diameter squared, which is 0.6 times 0.6 times the height, which is 0.8. That gives us 0.288 cubic meters. That is the volume of one drum. We were given 60 drums. And so to find the volume of the total drums, we will multiply 0.288 times 60, which gives us 17.28 cubic meters. Now, transposing in the stowage factor formula to determine the weight would be equal to the volume divided by the stowage factor. Therefore, 17.28 divided by the stowage factor of 0.7 would give us 24.69 tons. Now, we have both the total volume and the total weight, and for them to be able to hold in the particular container, they must be less than the given volume and the given payload of the container, making them able to be transported together. So let us look at the solution. Combining the volumes and the weight for both cargo, we get total volume would be equal to 17.28 cubic meters plus 11.38 cubic meters, and that gives us 28.66 cubic meters. Total weight is equal to 8.75 plus 24.69 would equal to 33.44 tons. Since the volume of the container is greater than that of the combined volume of both cargoes, given volume 31 cubic meters, is greater than 28.66, then the volume is okay. Let us look at the weight. The maximum payload of the container was given as 18.7 tons. Now, this is less than the combined weight of both cargo, which is 33.44. Therefore, the weight is not okay. Once one of the consignment is not okay or is greater than the given specs or the given dimension in terms of payload and volume, we cannot pack these two. They will not hold together. Therefore, the answer for A would be no. The answer would be no. Let us continue solution. They ask us to calculate the volume usage, which is equal to the total volume of the cargo divided by the volume of the given container. Here, total volume is 28.66 cubic meters divided by the given volume of the container, 31 cubic meters, times 100, we get 92.45, which is equal to 93%. Now, let us look at the other section. Based on the given internal volume and the maximum payload of the 40-foot container, we get a stowage factor of 2.44 cubic meters per ton. Now, since the weight usually go over the volume for any container, any cargo that is within the stowage factor of 2.44 can be safely loaded in such a container. Now let us look at this. The stowage factor of the thinset is less than 2.44. Therefore, using the weight, we can ignore the volume because the volume would be fine. Also, each bag of thinset weighs 35 kilograms. We can convert the actual payload of the container, which is 27.5 tons, to kilograms. Here, 27.5 times 1,000 gives us 27,500 kilograms. Now, the number of bags that can hold in the 40-foot container is equal to 27,500 kilograms divided by 35 kilograms. That gives us 785.71 bags. Again, that is 785 bags of thinset. Now, let us bear in mind that once you're given the space or the volume of any area and you have the actual weight, the payload of such different items that you want to put in that space. Once you bring the space to the same unit as the individual item, you divide it and you can determine how many of such an item can hold in a space. Remember, with the volume, the space is fine. When you work with the payload, it gives you a more precise determination of if it can actually hold, because you'll be working with the actual payload and the actual weight of the individual item. And that will give you the total that can hold in such a space. Okay, remember, please to like, share, and subscribe to this channel. We intend to continue with the next episode of realistic scenarios. Please don't miss the next episode, which is going to be very, 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 can't stress it anymore, important. Looking forward to see you all. So join me next time. Laying out.